we started with variables, and variables can be integers, floats, strings, stuff like that. So if we just basically create x as a variable as 5 and we want it to print, it's 5. We can make it 5.7. We can make it anything. We can make y a string saying welcome to the jungle. So any Guns N' Roses fans out there or Bengals fans, any sort of Tiger sports related fan, welcome to the jungle. There you go. So the first kind of thing, so over the next few weeks, we're going to kind of work with these different data containers. So this week, we're going to work with lists. And then over the next few weeks, we're going to work with dictionaries, tuples, things like that, that are basically going to allow for us to store and contain information in different ways. So the first one that we're going to learn with this week is lists. So lists, basically to create one, you just create square brackets around it and you have commas separating all of the items in the list. So to create a list, if we wanted to convert x from this float of 5.7 to a list of items, you will basically just do this. You will set the variable name and then have an open square bracket, put everything in there, separate it with commas, and close it with another square bracket. And then if we ask what data type X is, it tells us it's a list. So we can even so you might be wondering, okay, happy can happy be in the list? No, because we didn't put it as a string. So we need to make sure that when we are creating a string, we put the quotation marks around it. So now we can have a list that has numbers and the word happy in it. It doesn't really matter as long as it is a valuable or a real data type, then it can be stored in this container. Now, we're learning about things within the context of lists, but another thing that might be important for you as we start working with lists and other types of data containers that aren't just one item. They might have a number of characters, but they are a specific one item, is that Python indexes things starting at 0. So one in this list, 1 might be the first item or first item in the list, but the problem is that if you were to call the first item in the list, you might be instinctually saying, okay, I want to call 1. I'm going to call it x1 or something like that. The problem is that Python indexing starts at 0. So the first item in the list is going to be denoted as 0. The second item in the list is 1. The third item in the list is 2. The fourth item in the list is 3, so on and so forth. So if you have like a million things, 9999999 would be the millionth item in the list. So if we want to call a specific item from the list, if we have this print statement here with x1, what that's going to do is it's actually going to call the second item from the list. So before, when I did this before, 2 was here, but now that happy has been replaced with 2, we will actually, it should print out happy, and it does. If you wanted to call multiple things, so we can basically index, pull from a range in the index within the square brackets. So what we want is we want x, which is the name of the list. We want an open square bracket. We want the first item that we want it to call, which is going to be the first item, which is 0. And then where do we want it to stop? So you might think instinctually 0:2. So from 0 to 2 would mean that we would call the first, the second, and the third item, but it actually doesn't call the last item listed. So it'll go 022, not inclusive. So in this case, if we do 0:2 within square brackets, it's going to call the first 2 items in the list, which are 1 and happy, which is what we got below. So if we switch this to x3, we should get the 4th item in the list, which is 4. If we switch this to x:4, we should get the first 4 items in the list, which are 1, happy, 3, and 4. If we want to print the first 3 things in the list, we get 1, happy, and 3. Now, you might want to do things in a, let me see, sorry, I didn't see the chat. Okay. So I'm not sure if that's in reference to the question about why does it work like that. Was that in reference to the index ordering or the actual fact that the index starts at 0? So basically, different programming languages kind of set the index at 1 or 0 based on, I don't know exactly specifically why in terms of the reasoning behind the indexing. So I used to work with R, and I'm pretty sure it was the same. Part of me wants to say that C might start at 1 as the index, or no, it doesn't. It starts at 0. I'm not sure. Okay, so, well, R also starts at 0. So Python also starts at 0 in terms of indexing. So different languages choose 1 as how they start indexing. Python starts at 0. I'm not 100% sure why, but that's basically, Java starts at 0. Okay. So I'm not 100% sure why. It seems like the majority of them use 0 as the indexing starting point. But yes, it's very confusing. If you're like, okay, well, I want the 4th element. Okay, though, that's 3. So usually the more you get used to this, the easier it becomes because your lists aren't just going to be 1, 2, 3, 4, 5 usually. So you're not going to be kind of mapping it. Like you could change this to emotions. So sad, happy, bored, angry, indifferent. And then the indexing doesn't become as kind of problematic because you're just pulling items out. Okay, well, the 4th element is angry. And then the first 4 elements are sad, happy, bored, angry. And then if you rearrange these will express differently. So what we're going to do in a little bit is we're going to rearrange some of these lists. So when you are pulling things from the list, you have to be careful that you don't change the order on them because it might change what you're pulling from. Okay, so yeah, indexes start at 0, counts start at 0 unless you set it at 0. So some people would choose their counter just to be set at 0 and then do the plus equals to make it 1, make it 2, make it whatever. But yes, so your indexes start at 0. So whenever you're calling a specific ith or jth element from a list or some other type of container, you're always going to start with 0. Now you could also go backwards and you could start from the end and move towards the front. So putting a negative sign here means that it's going to call the 3rd to the last element. So if we go to the 3rd of the last element and we work backwards, well, then that would say it would go from 0 to 5. Well, it would be 4, 3, 2. So it's only going to call the first 2 elements of the list. So your first element was sad, your second element was happy. So if we do 3, then it's going to call the first 3 elements of the list. But if we do -3, basically -1 is your last element, your second to last element is -2, your third is -3. So if you go backwards, you can actually have sad, happy, and bored being your 3. Well, it would actually just be sad and happy because it would say, okay, well, how many elements do I have? I have 0, I have 1, I have 2, I have 3, I have 4. So if you kind of operate this way, the last element is -1. This is -2. This is -3. And then this would be -4. So if we did 0 to -4, it should only call the first element of the list. comment this out or else I'm going to get an error. So there you go. So basically we count up from 0 in terms of elements, we count back from -1 from the end. So you might think, okay, well, if I did -1, well, wouldn't that just give me the last element first? If you do it this way, it's going to start from so you could do like -1 to -4, right? I think it's not going to give you anything because you're starting from the end and there's nothing to the right of it. But let's say you want to reverse your list. So if we take this back from emotions and we go to just numbers again, 1, 2, 3, 4, 5. Okay. So 1, 2, 3, 4, 5 pulls the fourth element is 4, first 4 elements 4, first 3 elements 3. It's only going to call the first one here. So if we do -2, it's going to call the first 3 elements. What if we want to do them backwards? What if we want to go in a reverse order? So like, let's say this is the alphabet, or these are the numbers. And instead of it being 1, 2, 3, 4, 5, we want it to be 5, 4, 3, 2, 1. Well, there's actually a reverse command. So if you take the name of the list, dot, reverse with open and close parentheses, it will automatically reverse the list from back to front. So it's not going to sort it necessarily by lowest to highest. It will just sort it from whatever your elements are to what they are now. So like if we make X 1, 2, 4, 5, 9, 3, well, that's not in numerical order anymore. So if we reverse the list, we're going to get 3, 9, 5, 4, 2, 1. So it's not going to sort them by number, but you can sort in ascending and descending order. You can also sort by alphabetical order. We'll get to that in a second. So I've made a list here, Y, with all of the public high schools in Muskegon. Yeah, you can do randomization as well. So there's a package called random. So I'll show you an example of this in just a minute, where like if you want to randomize integers or randomize lists, you can use randomize with the random package like you did with math. So if there are 12 public high schools in Muskegon County, which I think is a lot relative to the population, but here we are. So I have these in alphabetical order, but if I want them in reverse alphabetical order, I could just do Y dot reverse, like I did up above for the number list. But another way in which you can reverse the order of lists is by doing Y : -1. And so what that's doing is it's basically, these colons are basically indicating what's to the left, what's to the right, what's including. Well, if you do double colon, it's just saying everything. And then it's saying you're starting with the -1 element. So basically, this, even though you're not using the reverse command, does the same functionality, where instead of these originally being Fruitport, Holton, Moda Shores, Montague, Muskegon, Muskegon Heights, North Muskegon, it's now starting at the end of the alphabet with Whitehall, Reese, Puffer, Ravenna, Orchard View, Oak Ridge, et cetera, et cetera. So you can reverse order things with reverse. You can reverse order things with the indexing, stuff like that. Now, what if you want to add something to your list? So you have a list here and you want to add something to it. We could just edit the list in the code block and say, okay, well, I want to add Colorado here. Could do that. You can also use the append command, which basically will attach anything onto the back end of the list, whatever you command. So later on, when we learn about loops, this is what a lot of people will do with input putting information. So if you have people like typing in information into an input, so like what's their name, what's their date of birth, stuff like that, you can actually just append on their name into the next item in the list. So if we want to add Colorado to the list, we would just do states, which is the name of the list, dot append, and then in parentheses, you put whatever thing you want to add in here. So you would print states. And so now we have Colorado in here. Okay, so let's add Connecticut. Okay, so we add in Connecticut. So now we have this state on. So you can just keep appending a bunch of states in here until you get to all of them. Now, what if you want to get rid of one? Let's say that you don't like Alabama, so you want to get Alabama off the list of states for whatever reason. Then you would just use the dot remove command. So states dot remove Alabama. So it's going to pull in and map it and remove it if it's there. So if it finds it, it will. So let's say we want to get rid of, I don't know, Kentucky. Okay. Well, Kentucky is not in the list, so it's going to give you an error. So it's got to match up with something in the list. So if we try Alabama again, it's going to give me an error again because we already took Alabama out. So if we bring Alabama back in, well, it's going to give me Connecticut twice because I'm adding Connecticut. So let's remove Connecticut because we're like, oh no, we've got Connecticut in here twice. We can remove Connecticut, and then we've got only one Connecticut now. Now, another interesting thing is you might be like, okay, well, can I add a string? Can I add like, let's do, instead of states dot remove, let's do states append. Let's add 5. Why not? Add the number 5 in. Well, whoops, I don't want to print 5, I want to print states. There we go. Okay, well now 5 is appended in there. It's appended twice because I ran this command twice. Okay, well now we want to get rid of 5 and then print it again. I want to get rid of this. I want to move this down. Boom. Now we have 1 5. Well, we want to get rid of the other 5. Okay. So see, it's a different data type, but it's a integer or a float, but it's still functioning within the list. The list is just kind of sorted into its index. And so if you keep it in the same order that you filled it in, you can call anything from any point in the index. And yes, you can remove more than one item at a time. So you could remove, I'm pretty sure you could remove California. Oh, guess it only takes one. Probably could remove more than one at a time, but there you go. California's gone. Let's add it back in. Now it's out of order. Oh well. You know what I learned today, or learned the other day when I was making this list? We all learned how to do states in alphabetical order. But I feel like that song is not in alphabetical order. So Alabama, Alaska, Arizona, Arkansas, California, Colorado, Connecticut. I guess it is in alphabetical order. For some reason in my brain, I was thinking that one of them was out of order, like Connecticut was before Colorado or something like that. So I guess the song still is correctly in alphabetical order. But anyways, what if we want to add the state capitals to our list of states? Now, this isn't really a good functionality of a list. Like if you wanted states mapped to capitals, you'd want to use like a dictionary or a tuple, which we'll learn about next week and the week after. But I wanted you to see that you can actually append a list onto a list, but I want to see kind of the uniqueness that it creates, okay? So let's say we have the first three state capitals. We have Montgomery for Alabama, we have Juneau for Alaska, and we have Phoenix for Arizona. Okay, so we have another list. We don't just have a variable or an item, we have a list. So we want to basically add that list to our list of states. Okay, so if we do that, well, so now what we have is we have Alaska, Arkansas, Arizona. That's right. So it is out of alphabetical. Well, I have it. Alabama, Alaska, Arizona, Arkansas, California. So Arizona is actually before Arkansas. So that's why it was me that had this out of order. Anyways, so we have these states. We got rid of Alabama, so that's why it's missing. But now we have Montgomery, Juneau, and Phoenix all together as a list. So when I call the index for the seventh element, which is going to be 6, so we have 6 states here, and I call the seventh element, notice it's calling the entire list, not just Montgomery. So if you append an entire list to a list, the entirety of that second list is going to be one element of the list. So if I wanted to get rid of like Montgomery at this point, it's probably going to give me an error. So let's print. State here. So I'm going to comment out this other stuff so it doesn't rerun all this other code. I think there's a way. I think I'm trying to remember the short key that allows for you to see. Montgomery is not seen as part of the list, even though it's a part of the list within the list. So how are we going to get rid of this? Well, you can go back and just get rid of it, but let's see if we can try to remove it via the element number. No, because we're out of range. So so that's one thing that you have to keep in mind when you are working with this, is that if you want to append things, it's going to stay contained in the type of thing it is. So you might think instinctually, I can append this and then I'll have 9 elements instead of 7 elements. Yeah, that should work. Let's try that. No, that should. No, because it's not defined. That's right. So we'll work through that. There's an easy way to do it. I'm just when I'm doing all this on the fly, my brain tends to shut off sometimes. So yes. So you would put. So you're saying you want to get rid of Montgomery, you could put Montgomery in there to remove from the element. It's possibly that'll work. There are other things that we can do with this. So there are sorting. We can sort this alphabetically. We can sort this. You can sort this alphabetically, but one thing that is important to note when you sort alphabetically is that uppercase takes precedence. over lowercase. So if you wanted to sort something alphabetically, it would actually like, so if you had like Alabama and like Alabama, it would take precedence to the first Alabama. And anything capitalized after it, then Alabama lowercase would be at the end. So like if you had Alabama, Alaska, Arizona, so on and so forth, it would end up reporting Alabama, Alaska, so on and so forth. So let me stop this for a second because I want to make sure that you can see it. My problem is that I'm on a different computer again today, and it will, I want to make sure that you're seeing my notebook when I do this. Let's see here. Where did it go? Here it is. Oh, you can't see my screen right now. So let's try this. So you can use the sorted command for states. State sorted is equal to sorted state. Whoops, that's supposed to be underscore. Underscore. There we go. What's going on? That's why. The reason why it's giving me that error is because of the list being part of it. So let me reset states to just this. And we'll put Alabama. Well, we'll put Alabama here so we can. I don't want, okay, so okay, now we got that. Now we're gonna jump down to here. There we go. So when you use sorted command, it'll sort things in alphabetical order. And notice that lowercase is put at the end. So even though we had Alabama second in our list, it actually is going to resort this to the end. And now remember, your index is based on where things are sorted to. So if you have something that you're pulling in terms of data that is very specific into the order in which you receive it, you want to make sure that you aren't doing too much sorting if your reference to it is very index dependent. So like, let's say that you're collecting information based on the order that somebody submits something. So we'll just say list, we'll say name list is equal to, I don't know, Bob, Susie, Greg, Michelle. Okay, well, you want to know like when they submitted the form. So when you submit the form, or you want to know who submitted the form first, well, if you ported in these documents or pulled these in from the order in which they did it, you would be like, okay, well, I want to print name list 0 for Bob, the first person. Okay, great. So I get Bob. But if I end up sorting the list, if I don't rename the variable as something else and I do sorted name list, okay, well, now I have Bob, Greg, Michelle, and Susie. But the problem is that I wanted to know who's first. Okay, well, Bob's fine, he's first, but then Greg is second here, but they were actually third in the order. So when you're hard coding something based on indexes, you have to make sure that you're not sorting anything. But if you're kind of like generalizing things based on index, then it shouldn't be as big of a deal.